Welcome year 6 to our math lesson. Today we're going to be reviewing coordinates, x and y. Grab your lined papers, your pens, your ruler, and let's get into it. Now, the first thing I want to say is that the reason why we use these line papers is because we need them for these points. They need to be equally spaced. Now, when we draw one of these axes, you have a line here and a line here. So each point needs to lay on this line, the next line, next point, next line, next point. I know it's a little bit slow to draw and it takes time, but we need it. We need the precision. We need to be accurate when we draw, and that's the reason why we have the coordinates in the first place, okay? So, Cartesian plane. What is the Cartesian plane? So the x and y is the Cartesian plane. Some scientists, some mathematician called René Descartes, who was born in 1500s, 1600s, named this coordinates, and he drew, well, points and shapes on them. So the important part is that it doesn't matter if you don't remember the name or the year. All you need to be familiar with is the word Cartesian plane. When we say Cartesian plane, that's what we refer to, x and y. Okay? Now, we have a point intersecting between the two coordinates, and that's the origin. We call it the origin because that's where it all starts. So this is point 0, 0, means 0 on the x, 0 on the y, and it's where both of the coordinates intersect. Okay? Now, on this coordinates, in this Cartesian plane, we have 4 quadrants. So what are the 4 quadrants that we have? We have quadrant number 1, number 2, number 3, number 4. Now it's important to name them to make life easier on us. It's very simple. It's very simple to memorize because this is 1, 2, 3, and 4. When I say coordinates, when I mean quadrant number 1, you immediately know I'm talking about this side, this section here. When I say quadrant 2, or the second quadrant, I'm talking about this side of the plane. Now, again, if we know this about these two coordinates, x and y, it's going to be easier for us to draw these paired or ordered pairs. What are these ordered pairs? They're points on the planes, so on the Cartesian plane. So first starts with an x coordinate and then the y coordinate. We also call them x component or y component. They're both the same thing. This point right here, 5 and 6, means first we move 5 points to the right and then we move 6 points up. Now you need to notice how the x and y have positive and negative numbers. So on the right hand side of the x are all positive, on the left hand side they're all negative. Up you go on the y, it's all positive. Down you go on the y, it's all negative. Now, it's important to be able to read these points. Then you need to remember the first one is x, the next one is y, meaning -3 in this example is x, the 4 one is the y. Okay, so this is -3, so starts from the origin, always, okay? And then you go to -3 and then you go up 4 points. That's your position, that's your point right there. It's like telling direction of a place, right? So, or you move into the door and then you go up in the elevators, same same as like that example. You move this way and then you go up, right? So let's draw these points on the Cartesian plane. Now we name these points A, B, C, D, E in order to make it easier to name the points and all. For example, if you have A, it's -4 and 6, that means -4 to the left and 6 up, which is right there. Okay, so -4 to the left and 6 up, it's right there. Now see how important it is to have these grid lines or to have these lines for you. You don't have to go back here. Imagine this paper doesn't have any lines. It's a little bit more difficult you have to always keep an eye on the 6, and so you can have a precise position for your point. Let's do this one. 2 and -3. Now I move 2 to the right on the x and -3 down, means 3 points down. That's B. Alright, so you can see with your eyes, try to locate it before I make it appear on the screen. So -6 and 4. -6 to the left, 4 points to, down. There you go. That's C. Now D. 7 and 3. 7 to the right on the x, 3 up. That's the one. Now, what do you notice about all of these points on the Cartesian plane? Each point lies on different quadrant. So quadrant number 1, point at it, it's this one. When you have any point in this quadrant, it's both positive. So it's +7, +3, because it kind of lays on the side where the x is all positive and the y is all positive. So everything in here in this quadrant would be positive. Now on the second quadrant, -4 and 6, you realize the x is negative, so any point in here would mean that it's -4, so it means in the second quadrant the Cartesian plane. Now the third one, both of them are negative. The fourth one of them is positive, which is the x, the other one is negative, which is the y. Now you don't need to know this for your exams. It's actually a good practice if you have, from now on, if you have any point without even locating it on the, without drawing it on the Cartesian plane, you know how, if you know in which quadrant x and y are positive or negative, you know roughly where the location is of the point. So that's why it's important to just hear about this, right? So we're done with reviewing coordinates x and y. Now let's move on to geometry. Okay, the slide says draw the axes for coordinates grid and number the axes from -5 to 5. Okay, so I have the coordinates. I draw with my ruler, and on this paper we have no grid lines. So we need to make equal spacing between each point. Now when you do this, you have your ruler, you draw the x-axis, you basically have the 0 in the origin, and then you move 1 centimeter to the right. From the origin you move 1 centimeter to the right, you have 0.1, move another centimeter, you have 0.2, another centimeter, you have 0.3. Now it's important you have equal spacing, so this will take time. This could take about 4 minutes to draw. Okay, both of them, x and y, or 3 minutes, or sometimes even 5, if like your points are, you want to be accurate and you want to take your time. Okay, now I want you to draw a rectangle within this grid. and label each of the coordinates, meaning each corner of the rectangle. I need you to estimate, like draw your own. I'm gonna draw my own on the screen. Now, my first 2 points would be on one of them is on the second quadrant, and the other one is on the fourth. Now, I have, as you can see, minus x here, and I have minus y here because they're in 2 different coordinates. Now, uh, what are the coordinates of the rectangle? Right. So can you see, notice how the numbers are repeated, sort of like, because when you have 5 here, there's no way that the other point goes left and right. Like if I catch this, or like if I take this point and I move it all the way over here, this shape will no longer be a rectangle. Now again, same thing here. So you see that some of the points need to repeat, such as the x points, right? -6, -6, 5, 5, and only one that is altering is, well, this one is 4, and this one needs to be in the same level, which means the same point on the y. This one needs to have the same level, which means it needs to have the same level, the same point on the x. Okay, now you can measure the sides for this rectangle. Say if I want to see what's the length of this rectangle, I would just go, and I know because this line is like saying it's here, I would go and just measure this. I would just count this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it could be 11 centimeters. Now I can measure this side with this y-axis, and by the way, I'm measuring length. I'm not measuring points. I'm just measuring the length, like what's the length for this distance, right? So I'm measuring 1, 2, 3, 4, 5, 6, 7. So I'm thinking 7 maybe. So it's 7 by 11, and you can find the area for this rectangle by multiplying 7 and 11. You can see how this makes your life very simple. If you draw the points 7 centimeter apart from each other, you can see that this is a very geometric and precise shape. Okay. Now let's draw isosceles triangle. So also a triangle would actually have 3 points, right? So 3 points, it really in 3 different coordinates. Now, as you can see on the screen, that line is just the line for making sure that it's an isosceles triangle. Okay, so it could also, you can actually shift this if you know how translation, reflection, and rotation work, which we are going to cover in a bit. You can move this triangle how you want. So let's get into it so we can move on to this one. Okay. Now, a parallelogram, on the other hand, is sort of like a rectangle. It needs 4 corners, but a parallelogram is like a rectangle that's pushed to the side or tilting to the side, so the points can be drawn like this. Okay, now you need to remember that between this point and this point, right? So this point is 8, and I can see that this point is 4, right? So between this and this distance between them needs to be the same distance between these two. So you don't need to, if this starts too complicated, again, then you don't need to know that. all you need to know is that just like a rectangle, the sides needs to be the same length, otherwise it's not a parallelogram, because parallelograms have parallel sides. These two sides are parallel, meaning they will never meet even if you extend them forever. These two sides the same. And imagine if you have this point right here, and well, the line will shift to here, and imagine if you extend that, at some point it will actually meet with this other line, so it won't be a parallelogram anymore. Okay, so let's move on to translation of shapes. Okay, on the coordinates, you can see that this rectangle has moved. Now, as you can see, when something moves, when shape moves, the points also change. Okay, but to give you good news is that if this point right here, okay, moves, for example, okay, let's see how it moved. So 1, 2, 3, 4, 5. It moved 5 to the right of the x, then moved up 1, 2, 3. Moved 3 up. So this means that if this point moved 5 and 3, meaning 5 to the right, 3 up, the other 3 points also made the same movement. Now let's check. Now this point's supposed to be this one, and it should have well, according to what I'm saying, this should move 5 points to the right, 1, 2, 3, 4, 5, and 3 up. You see 3 up. Same thing here, 5 to the right, that's 1, 2, 3, 4, 5, and 3 up, and that's 3 up. Now same thing here, 1, 2, 3, 4, 5, 3 up, 3 up. So that's the translation. Alright. Now what about this triangle? You see that it changed directions, right? The triangle is no longer standing on this side, it's standing on this, well, point right here. Now let's see how the points of this triangle moved when we move the shape. Okay, so we know that this point right here is this point. All right, so well, this point actually kind of rotated 180 degrees, right? So if this one, well, came here, so it rotated 180 degrees. Each of these points, like even this and this, they both rotated 180 degrees. You can tell that it moved 180 degrees because it moved from this corner to be in the other corner, right? So it's like that. It's rotating 180 degrees. But it's worth to mention this shape, triangle, it didn't move or rotate according to a center point. Like if the center point of the triangle is like right here in this point where I have my cursor, if the triangle rotated around that center point in the middle of the shape, it would be different than this. This one moved around the center point that's here. Okay, we made this point stationary. We didn't move this point. We only moved the points. Okay, so actually I'm not sure if it's 180 degrees. Now if you have a point right here and this, but then it flipped, so yeah, it flipped, so it is actually a lot of degree. So because if you make this one a reference point, move away up until here, and this one moved all the way up until there, and this one moved all the way up until there, it sort of is like 180 degrees. Okay, so what is this one? This is translation. You can see because the shape didn't rotate, it didn't change directions or anything. What about this one? This one, the shape kind of moved and it's no longer standing on this one side. So this one is not translation, it's rotation. Okay. What about this one? Oh, this one is more like a rotation. And it's not a translation. Okay. So to describe a translation, you have to say that how many squares it has moved to the left and how many moved to the right. So just like we said right now, each point, each corner of the shape makes the same movement as one of them. So if this one moved like that, and this one, the other points also moved the same way. All right. What about this one? So it moved 4 squares to the left, 5 squares up. All right. So as you can tell, now the shapes are staying the same when we do translation. Now I'm just quickly showing you this so you understand translation better. Okay. So there you go. That's how the triangle moved. Okay. Now moving on, and this was a parallelogram. See how that shifted. Okay. All right. So moving on to this question. It says, using a grid line with coordinates, draw the following shapes where one corner is at the given coordinates, writing the coordinates of the other corners. Meaning, from only one point, you know how to draw these 4 shapes. Now, I want this to be a homework. I want you to draw a rectangle on the x and y axes. One corner is -8 and 1. Now, I gave you this. It can be a rectangle that is, covering to the first 2 quadrants, or covering the bottom quadrants, okay? Because it's -8, it's to the left, and it's 1 up, all right? So a triangle, square, and a parallelogram, all right? Now I want you to use your grid lines or lined papers, and I want you to submit it in the homework section with this lesson, okay? Now, if you have any questions, please don't hesitate to ask, and I hope to see you next time.